webinar of this series. And for this last webinar, I have invited someone that I've worked for a long time. It's really someone that has a big influence on my career. We work together.
The other way around. The other way
No,
around.
no way, no way, no way. We're working together, creating a training center, which is for Raman Dental Education, which I'm very proud to be a part of the beginning. Nowadays, it's much better because I get out. But anyway, it's something that is one of the best training centers I know in the world. It's not quite a new university, but very clinical. It can prepare you very well with patients treatment and everyone and everything else. So, with no further delay, I'm very proud to present my very good friend, my guy, okay, Pedro Moura, okay.
Hello, guys. Thank you, Rui, for the invitation. What we're going to do today, we'll have a webinar, a step-by-step webinar, a very technical webinar. What we're going to try to do is show you how we perform bone level guides, which can be tremendously useful for collecting bone from the retromolar area, for the sinus, and etc. Rui has suggested me that we actually recorded this webinar. So we have this pre-recorded. We're going to play this presentation. And of course, I'm going to try to answer some of your questions at the end, okay? So I'm going to now play this webinar. Hello, guys. Hope you're doing all right in this pandemic, in the strange pandemic times. First of all, thank you for being here. I'd like also to thank Rui. Rui has been my mentor, taught me many, many things along the years. We've worked together for 3 years on a educational program, which is Foramen Dental Education. I am still lecturing every day at Foramen Dental Education. He has founded that company with me, and more importantly to me, he has definitely taught me all the basics and everything that I really know about surgery. So he has been truly a mentor. This is a word that gets thrown around a lot, but truly he was a mentor to me and still is. I still admire him a lot. He is now dedicated to his business, Bone Easy. He's bringing all his talent into the development area. So when he asked me to deliver a webinar, of course I said yes immediately. And I proposed him to do something a little bit different, to do something very focused on a very technical webinar, actually, something that you could actually bring something home with you. So I'm going to teach you today 3 methods for collecting bone. And this is something that I do routinely in my practice. I do a lot of bone grafting, and lately I have been teaching my students how to do it, how to plan it, and how to effectively produce a guide using a inexpensive software such as BlueSkyBio. And this is exactly what we're going to do today. We're going to use this software to plan and to actually produce some surgical guides. We're going to take a look into Curie approach. We're going to have a look also into sinus. How can we execute a sinus lift using this software, and also take a look at some grafting in other unusual areas. So I'm going to start this presentation by using BlueSkyBio. I've actually already opened the file that I'm going to work with today, and we're going to start by well, I'm going to start by describing the case. This is a case that obviously needs some kind of bone grafting on the anterior area, and we could do this many ways. We could do this by a regenerative approach with biomaterials, etc. But I am a fan of using autologous bone, so this would be a great case to use some bone collected from this retromolar area right here. Typically, this is what I would do. This is a nice defect, not that a very favorable defect, particularly this one. This one not so much because we're missing this palatal, the palatal area as well. So we could take a look into reconstruct this portion as well. But typically we would approach a situation like this by collecting bone from this area, from the retromolar area. Now, one of the things that I think that is very helpful when using this kind of software and when using this kind of approach is that I can easily plan this surgery, or have a student of mine plan this surgery and can send this file over to him. So not only I am planning and executing my surgeries with this, but I'm helping others understand exactly where they should place their guides or should collect their bones. So it's also a very interesting instrument for communication between surgeons. So without further ado, I'd like to explain you how do I do this. So the first thing that you need to do, you need to produce a guide without any guide holes. You know, you need to produce something that will go onto this area. Now, one of the problems that immediately you can notice is that this is a CBCT. So this is not as precise as a CAT scan. You know, when we're doing this on the CBCT, what you will find typically on the maxilla, you will find these problems like right there. You will find some holes, and these holes can be quite complicated when we're trying to produce a surgical guide that lies against the bone. But on the mandible, on the other hand, it's quite possible to do this because it's so dense that most of the times it really just doesn't matter. You can produce a guide that lies against the bone without many problems. So so this is exactly what we're going to do. We're going to get rid of the maxilla by I'm clicking isolate, and I'm now going to click on the mandible. So I'm getting rid of the maxilla, and this is because we have a nice CBCT to start with. So these teeth were not in occlusion, so this makes it really much easier. And now I am right now I'm playing with the threshold, and you have to decide at some point. You have to decide what do you want to create as an STL surface, because right now the only thing that I have here is decomp file, so I have a CT surface, and I want to convert this CT surface into an STL surface. And when you decide that you've got a nice surface to work with, then what you're gonna do is create model. So now we are creating our guide on this STL surface, okay, this STL surface right here. What we're gonna do is we're going to our guide panel, and just make sure you have this. I like to work with this on advanced mode. And what we're going to do, we're going to create a guide that is 2 millimeters thick, and we're gonna we are not removing retentions. Okay, we're gonna have a bone that fits really tight against the bone. So this by default, we have other values by default, 3 millimeters, I believe, and we are removing retention. So make sure you have this, because this is important. And now what we're going to do, we're going to select mandible. Okay, so we're going to hit the shift key, and I'm going to draw a fairly large selection. And we're going to go through here, and we're going to connect it. And actually, I want it a little bit bigger than this. Now, pay attention. Bear in mind that on this module, on the surgical guide module, what you'll have is a fixed insertion axis. Now this is important because the insertion axis is always perpendicular to the occlusal plane, so it won't necessarily be the best for this kind of approach, but sometimes it does work, and when it does work, you can use it, and the workflow will be very, very simple. Now I'll show you in other situations another workflow. What do I use when this approach is not possible? Now once you have your selection, and I'm going to go a little bit more into this retro, into the Ramos actually. I'm going to go here, because it doesn't matter if it's too big, because you're going to cut it anyway later on. So now I'm going to select create surgical guide. It warns me that it's not compatible with the burr kits are not compatible with all implants, so I'm going to hit yes. I'm going to continue, and now the software shall fabricate our surgical guide. So you will have something that fits very tightly against the bone. Now, what you need to do next, you need to find a way to stabilize this, to make sure that you're on the right spot. Now, if you're having an edentulous mandible, you might consider to place some osteosynthesis screws. This reminds me of some guides designed by Luca D'Stavoli. He has a company that designs this kind of guides, and actually I've seen his work before. I have been inspired by his work, as many of us, and he has some articles describing that, so be sure to check them out, and be sure to try his guides out as well. And you can do this kind of approach inside the software as well. And what you need to do if you're having an edentulous patient, you need to have an osteosynthesis screw. You need to have some way to stabilize this guide. When you have a dentate patient, you might want to have some kind of support on the occlusal area. As you can see, the software has now produced a nice, very tight guide. Again, this is not possible with all cases because of the insertion axis, and also because of the density of the STL file, or the density, if you will, of the DCOM file. And because of that, you might want to actually segment, manually indicate the software what is bone and what's not bone, and then draw and fabricate your guide from there. Now, what you want to do in a case like this, first of all, what I'm going to do is reduce it in size. I know that you can do something if you see a window that says place a window or something like that. My software is in Portuguese, and when you click it, you have this nice window, and you can select. You can even input the size that you want. So let's take a look at what actually we do need. We're gonna check tooth number 22 and 12, and let's say you want a bone graft and you want to use the cortical, you want to split it and use cortical shells, and then with the other half you want to scrape it and use it to fulfill this area. Now you will need, for this case, you will need something like 10 millimeters for these tooth and about 8 millimeters for tooth number 12. So we're actually talking about 18 millimeters. So let's make it 20 millimeters, so we have some maneuver, so that we don't end up with the too small of a graft. So we will need 20 millimeters, and you will split it in half and use the other half as a graft, or you're gonna scrape it with a bone scraper. I typically do that. Corey typically does that, and so you would want to input that size. You would use that value and put it right here, and put 20 millimeters here. Yeah, and what you need to do now is just place it where you find adequate. I'm gonna turn transparency a little bit so I can navigate much better, and I'm gonna place this graft a little bit more, just position it a little bit better now. Okay, zoom in. And I'm gonna go to all the way to this area right here. That's my goal. That's what I like to do. Some of you may do it a little bit different. This doesn't matter. Just trying to show you some steps, and this is how you can improve what you're doing with digital technology. So you'll be sure that you have a graft that represents exactly what you were planning. Okay, you have to make sure that that it will trespass. I'm gonna bring transparency down a little bit. You see this little bit right here. You need to make sure it's not present, and also all this area here. I'm gonna hit this ball. This will change this square, rectangular in this direction. Okay, so I'm gonna take a look in all directions. I'm gonna make sure that I have. Actually, I don't like that we have that it's so thin here, so I'm gonna make some changes here. I'm keeping this fairly simple. You could complicate. You could use many shapes here to obtain a more complex shape. Of course, I'm gonna take a little bit in this area. Okay, so just imagine that you're okay with this. And I'm actually gonna make it bigger on this. Yeah, maybe like this. Maybe like this will do the trick. I typically take no. Still, sorry guys. I'm gonna do it more like this. This would be much more adequate, I think. This will produce a much larger graft. Okay, so now we have a different dimension for what I was planning at the beginning, but you got the point. You could just, if you want to be really precise with the size of the graft that you're going to collect, you can do that. But I'm going to assume for a moment that I am here on the right position. I have the right amount, and I'm gonna, after I have this done, I'm gonna go to my panel guide, and I'm gonna select again, create surgical guide. Make sure you have your correct model selected, and what you're gonna end up with is you're gonna end up with a hole on this surface. But this hole is precisely what you would want to have, because it will guide actually your piezo. Typically this is done with a piezo what will guide your piezo won't allow you to collect bone from a different area. Now, you could do this a little bit differently, and I'm certainly doing it differently. I just wanted to show you this process, but you could use not a window, but you could use just a positive side. Just imagine that you're gonna leave the guide in such a way that you're gonna cut from the outside. What this allows you is to use a much smaller guide, will easier to fit, and this in surgery certainly makes a little bit of a difference, I think. So we're now fabricating our guide. Okay, then now we have our guide. You can see you need to check on this. First you need to turn this on, and now when we are here, you need to check that you are on the right, that you have an adequate selection. Actually, this guy has a lot of bone on this area, so this will be hard to collect some bone from here. Okay, this is a very cortical bone. This will be very complicated. Normally, you will have about 3 millimeters in this area, and if you go a little bit more to the lingual side, if you go a little bit to this area, we'll find some medullary bone. It will make it really easy to remove this graft. But on this particular graft, I can see that we're gonna find some trouble here clinically. It won't be that easy to collect, but it's all cortical bone, which is nice. Cortical bone, it will give us very, very nice shells, and it's very easy to scrape bone, and we're gonna have a nice volume also. So you need to check out if this is okay. If this is on the plan, you can see the nerve is pretty distant, so you could have really, really big guide. It's really deep. It's really on the lingual side. There is absolutely no way that you're gonna hit the nerve or have any kind of paresthesia. That just won't be the case. But to finalize this, what I would do is I would select it and use this cut tool, and I would do something like this, and I would just trim it like that. Maybe you could do some trimming on the outside as well. So 3D print this, and then you would actually by hand manually trim it, share side or whatever, and maybe a little bit too thin here, maybe a little bit too thin. You don't want this thing to break. You need to have some resistance, and yeah, it's fairly okay. Maybe you want to be a little bit more precise and spend a little bit more time to this, and I won't, just to show you how you could do this kind of guide. But nowadays, I'm not using this kind of guide with Winder. I prefer to use I prefer to make my cut like this, a very simple cut. I wanna get rid of everything that doesn't matter, just like this, and I'm gonna cut on the outside of the guide. So this makes much more sense to me. Okay, what you wanna do is you wanna check if you're on the right position. Always checking this. So this is something that many softwares won't allow you to do it. So you could do this kind of guides in many softwares, but at the same time getting to know what really is going on the bone. So having the CBCT, there are not many softwares that allow you to do it, and certainly not many free softwares that allow you to do it. So BlueSkyBio is truly a blessing in that sense. You do have to pay to export these guides, but really you will pay per case, so you don't have to make a big investment. So let's say this is what you wanna do. So you have two kinds of guides here. Now, none of these guides you can stabilize. None of these guides are guaranteed to stay in place. What you need to do, you need to import an STL. You need to have an STL file. I happen to have a intraoral scanner. I use Medit, and I do have a scan of this patient. I'm going to import it here now. Okay, software is asking me if it's a mandible or a maxilla. It is a mandible. And there are some bugs on this version of BlueSkyBio, so sometimes it aligns correctly, sometimes it aligns automatically, just like the way you're seeing here. So what you'll have to do is an alignment by points. And we will do this now. We will select every other tooth. On our DICOM, and what we will be doing on the right window is exactly the same. We're actually going to skip this route. I need to do something about that route later. And what we're going to do here is exactly the same thing. Well, a little bit tricky here too. I'm using the trackpad instead of a mouse, so a little bit tricky. So I'm gonna skip this one, use this one, this one. I'm gonna hit the OK key. So this shouldn't be a problem because it's okay. You can see it's not a problem. This is a good sign. The fact that you have two colors here. I'm just gonna hit save. You need to be saving these projects many times. Okay. So now what you want to do, you want to connect this guide to a guide made on top of these teeth. And to do this, I only actually use one tooth for this. So I'm gonna actually use only this tooth, but I need to have some kind of guide or a splint or whatever without any guide tubes on top of this tooth. So we're gonna create a guide here. So I'm gonna hit the panel guide, and we're gonna change this. We're gonna have, well, actually, we can have 2 millimeters, but we're gonna hit this. We're going to remove retentions, and actually, what we're gonna do, we're gonna only use this part of the occlusal surface and the sum of the vestibular. That's what we're gonna do. So we're gonna deselect these, so you got a very nice view of this file, and not that perfect on the vestibulum though. I hope it's not a problem when drawing the guide, but I only need a very specific area, so it shouldn't be a problem at all. Okay. We're going to now hit Create Surgical Guide. And we're going to connect these two guides. That's what we're going to do. So this guide will allow us to have a perfect seating of this guide. When you see this guide seating on the tooth or being placed against the vestibular surface of the tooth, then you'll know that your guide is perfectly seated. It's because it's not that easy to be sure that a guide like this or a guide like this one is perfectly seated, because many times you don't get to see this area. So it might be a little bit off and you end up making your cut in another position. So what you'll need to do is some kind of connection. So I'm going to trim this guy that we now made. I'm going to trim it. You're going to use the cut tool. And remember, we're going to deselect it again. Actually, I want to see this from another perspective. Will be more like it. I want to remove this area now. And this area problem, yeah, I don't need it as well. Or this area at all. Okay. I'm actually gonna get rid of all this. Okay. Okay, very well. Maybe you'll need to do some adjustments to this intraoperatively. And if you do need to do them, well, then you do them. It's not a big problem. You just trim it a little bit more here on this area. Now, so what we need to do now is to connect this area to this area. Now, there are several ways to do this. I'm going to do things inside BlueSkyBio. We could actually do all of these things in the other software such as Mesh Mixer and ExoCAD, etc. But I just want to keep it simple here, and I would really like to maintain this inside this software. So what we can do is I want to go all the way to our tooth. Actually, to turn this on, this side do not need to be turned on. I want to go all the way to my tooth, yeah, to this area. Okay, and what I'm going to do, I'm going to add a nerve, and I'm going to add this nerve here. Okay, now the other part of the nerve, I want to add it here. And to do this, I'm going to go a little bit back, and I want to have the nerve. First, I'm going to click a little bit outside and now inside, because I wanted to make a sort of a little loop. Okay, so I'm going to deselect this, and now what we have is the two surfaces connected. If you find this to be too much of a loop, you can just try and connect them directly with only 2 clicks. If you want, you can add another nerve right here, but you will need to. I'm gonna shut the surface off for a bit. Okay, this is our guide. Okay, you see a guide that sits on the tooth and that draws perfectly what we need to collect, and it's connected by a nerve. Okay, to export this, you need to export these not separately but combined. Okay, you need to make sure when you are exporting that you are exporting these combined, and you can print these guides, and this will be a tremendous, for sure, tremendous help in your practice. So what you need to do, you need to go here and you need to select export data, and you're gonna export the surgical guide that you've designed for the bone collection. You need to export the nerve and the other guide. Okay, and you're gonna deselect this. Okay, this right here says export separate files. You need to select them combined. So you're gonna deselect this and then export. Okay. What you're seeing now is the actual case. Okay, let's now take a look at another example, and let's use the same case actually, and this time we're gonna do something on the maxilla, and you can see it's much harder than maxilla because I'm gonna isolate the maxilla, and we're gonna take a look at this model, and maybe we're gonna select this as our STL surface, and you can see there's a huge hole there. I'm gonna create model to start with. And now that I've got my model created, you can see that we have some pretty big holes on that region over there. And this creates a problem, because if you try to do a surgical guide there, then we certainly have maybe we wouldn't have this problem if we have a CT scan, but this is a CBCT, so this is quite different for this purpose, and it certainly poses a problem, and it also poses a problem because whenever you have these holes, the guide will try and fill all of this. So this will certainly be a problem. So a good idea would be to segment all this area. But we're gonna try to do something a little bit different. We're gonna have a guide for our sinus. Let's say we need a sinus on that area. I'm gonna do another curve here. I'm just gonna hit this draw panoramic curve. I'm going to select a few points along the maxilla and double click, and now I have a nice view of our maxilla, and you can see here we have what, 5-6 millimeters maybe. I'm gonna measure this. Where is it? Sometimes I get lost in this version. Okay, we have about 5 millimeters. So let's say you want to do a lateral approach. Sinusly, for sure, you could do a crestal approach. But let's say, for the sake of this example, let's say you want to do a lateral approach, and you want your lateral approach to be between, because here you probably have enough height to place an implant. So let's say you want to stay between these, like 2 millimeters, 2 millimeters away from the bone in any direction except this one. Or you could just choose not to involve the antral artery if visible, or maybe you could use it to avoid the pseudocyst on this side. Well, there are certainly some applications for this on sinus lift, or maybe you just want to be precise and know exactly where you are, or you just want to communicate with someone. So this is how I do it. Okay, what we're going to do differently, we're not going to use the same kind of guides. We want to use something different, because we're definitely going to have problems here, because the insertion axis here is completely is very hard for us, because the insertion will be like this, and when something that goes from the lateral area like this. And so to achieve something like this, what I'll need to do is go to the module, denture module actually, and we're gonna place some teeth. We need to place some teeth, to activate this module. I'm gonna select this 2 teeth, and I'm gonna place it anywhere here on the model, and I don't need them, so I'm gonna actually move them away from me. I don't want them around. And okay, let's put them this way. Okay, fine. Now I'm gonna check my panels, and I have this 2 panels on the denture module, and I'm gonna select visible teeth as a chain, and then we're going to select maxilla, and we're going to create a denture. Okay, and then what this next screen tells us, allows us to do, is to select how we want the insertion axis to be, and actually it's not all that bad, but we're gonna select something much more like this. Okay, you'll see anything that is on dark chocolate brown is a retention area, and everything that you see on this light brown is an area that is not retentive, so you're gonna have a very tight fit to the bone, which is exactly what you want. And now we're gonna hit next. Okay, so now you see a very weird model, because it's a model that has is very tight here and has all these retentions worked out on that area. And what we're going to do, we have we have these options of thickness and offset. What I like to do, I like to set my offset to, let's say, 0.20, because again, we're working on a CBCT scan, and we actually define this arbitrarily as a surface to work with on the threshold. Remember we had this DICOM file, and then we moved the threshold, and we decided, okay, this is the model that I'm going to work with, but it doesn't necessarily represent actually the reality. So we always have some kind of misadjustment, light misadjustment. So we're going to choose an offset of 0.2, and on the thickness, we're going to reduce this thickness to about 2 millimeters, and I think that will be just about right. I'm going to hit, we need, of course, to define a contour, and let's say this area, I'm holding shift, and I'm making my selection on this area. Again, I'm going to make this really wide, and then I'm going to trim it. It's not closed because this ball here, this little ball, needs to be like this. Okay. So the software will now deliver a denture base, actually, and we're going to use this denture base as our guide, really. Okay, so I'm hitting next, and now I'm going back to the surgical module, and what you'll see is that we have now this object that lies, actually we cannot see it because we need to have our cut a little bit differently, a little bit more like this. Okay, now we can see it. Okay, so you see it fits really tight against this maxillary bone. So this is typically how I do it. And now what you'll need to do is to trim it. If you want to know exactly where you are, you need to place some kind of element. And so what we'll need to do is to place an implant, and I'm going to place this personalized implant with 1 millimeter thickness, and I'm going to place it right, something went wrong here. Okay, I'm going to place it right there. Okay, and what I'll need to do is I'm gonna rotate it so that it will emerge exactly what I want. So there you go. You have your limit. Okay, your distal limit for this kind of guide. So you know, for example, you will know that you want to stay above this, because if you wanna, because below this, you will know that you will have bone. So there's no point in making our perforation there. So you can, for example, just remove everything that it's underneath. Okay, so I'm gonna do just that. Maybe more this angle. Okay. 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 And let's say I am going to cut like this. I'm going to cut it not like this. I'm going to like this, and maybe like this. Okay. So now what I do have is let's say we have this. You got the point. You just need to keep on placing implants or something that gets represented on this 3D view, so that you'll know which are the limits. And now we're going to need to connect this. We're going to connect this to some kind of guide that's going to be made on the STL file, just like what we did on the mandible, that will place this accurately onto the patient's mouth. And this is very important that you do that. Okay. We're going to align our scan. Oh. Okay, so what we'll need to do is just align it, just like the mandibular model. Okay, we have our alignment, and now we need to have something that will connect these teeth to this. And I'm just gonna, I think I'm gonna trim a little bit more. I wouldn't use something this big. I'm gonna actually remove it. Okay, it seems okay. And now we're gonna make, on our panel guide, we're gonna select the scan, gonna make sure we have our retentions removed. We're gonna select maxilla, and we're gonna create our guide. just around these two teeth will be more than enough, really. So I'm going to create a surgical guide and connect it. Just connect the two of them and export them. I'm going to trim it a little bit. So this is just like what we did on the mandible. Okay, seems okay. We're going to now connect the two guides. And select add nerve like this, and now my next selection point will now be the tooth right there. Okay, this way I am for sure not touching the bone, so this will allow me to effectively know that I have my guide in place. Okay, and of course you're gonna export this combined just like what we did on the Curie. Okay, let's take a look at this example, and what you're looking at is a couple of guides. This guide is made against a DICOM, so against a model obtained from the DICOM, and this guide over here is a guide that is made on top of an STL. And they are connected with these two nerves and the guide tube that will allow us for immediate implant placement. Now what you're seeing here is the position of the antral artery, and this large red mass is a segmentation of the sinus itself. This can be accomplished in BlueSkyBio by going to panels, and actually need to select model editing, and now going to our panels and select segmentation. And when you select this tool, what you need to is to indicate in which jaw, portion of the jaw you want to work in, and you need to select advanced maxillary segmentation, and you'll go step by step indicating manually what is whatever you want to segmentate. Normally bone, normally a structure that is denser than air, and this is basically the problem. This tool is made to segment something that is denser than air, and not the inside of a sinus, which is completely empty. But if you have a nice quality image, and typically a CT scan would be an example of a good quality imagiologic element, then you can obtain something like this, which is far from perfect, but it will serve us perfectly. And we definitely can work with this. You can select the limits of your bony lid according to the presence of the sinus or the alveolar process. You can see it just by adjusting the transparency. So this is definitely something that you need to take into account. This can be a great method. It doesn't always work, but when it works, for sure, it's a very nice option to have in your portfolio. Okay, guys, so before we finish, I'd like you to take a look at this case. Many times I find myself struggling to find areas next to my surgery to collect bone from. So whenever I can, I avoid going to the ramus if I'm working on the maxilla. Problem is, of course, there is not much bone available on the maxilla. But in some cases there are, and in this case, we certainly can find bone on the palatal surface of these teeth, a lot of bone. Actually, the problem is we will have the teeth roots on the way, so we need to make sure that we will cause no harm to these teeth when we are collecting our graft from the palate. So a guide is a very obvious solution for this, and what you can see in red is a guide designed on top of the teeth. This is a guide designed exactly like the other ones that I've shown you, and for sure I'm using nerves to actually connect this guide to a couple of guide tubes. Now these guide tubes are not for implant placement. You see implants over there, but these implants are over there because what I will guide through these tubes is a bone collecting burr. Many companies will commercialize these burrs, but I like them a lot. I use them a lot. And on a case like this, you can certainly guide a bone collecting burr through this guide tube, and you will know that you will be just on the right spot, and you are not inflicting any damage to the surrounding to the teeth actually. So I hope you have enjoyed this presentation. I hope you have enjoyed these three possibilities, three techniques, these three skills that you can add to your portfolio. I think it's very important that you know how to use this, because and how to use this properly, because you can adapt this easily to your own problems, to your own patients, to your own cases very easily. You saw three examples. They're not so different between them, and I mean, technique wise, I mean, the tools that I've used are not so different, but for sure this can make really a big difference in your practice, and it's not an expensive thing to do. And I find myself nowadays spending much more time planning my case and enjoying doing it, planning my cases, than actually time on the surgery. And my patients for sure thank me for that. And just the precision of the thing, it's just so different. It's just another level of control, really. Well, I hope you have enjoyed this, and now let's step into the Q&A section. Thank you.
Okay, I must say you never stop to amazing. So really, I didn't never thought about the idea of designing a nerve to make a connector. As you know, I use Blender, but there is one question here about from Andrea, and she was asking if you only use Blue Sky. I imagine no, you also use.
No, I do use Mesh Mixer. I just wanted to make this the simplest I could. I want to stay inside BlueSkyBio for this presentation, but I do use Mesh Mixer. I think it's a very competent and yet very simple program to use. I do use ExoCAD as well, not for this, for teeth, because I think ExoCAD is far superior for teeth than BlueSkyBio. But I do use a lot BlueSkyBio. Yeah. So if I can stay inside, it's going to be simpler for everybody, I think.
Yeah, it's a very good tool. Really, I didn't know that it worked so much. Like that, you could make so many things with it.
Yeah.
Really amazing.
It is, and right now I'm using the latest version, which is actually version 4.7, and it has a lot of upgrades to it. It has the denture module, so you saw me on the sinus using the denture module, so I can now define the path of insertion. Now, this is something that I couldn't do before, so it was very limited, because whenever you have this mandible or maxilla very steep with a very nasty inclination, on those cases you could not perform these guides. So now you can do them virtually anywhere. And also, it's very inexpensive. It's a very inexpensive program. You get to, I don't know, $20 per case or something. So that's very. Or there's always a lot of people that understand the idea. They want to do it, but they don't want to print it themselves. So I'm guessing they could use a company to do that for them. I don't know if you do this kind of thing at Moniz, Rui. Maybe, no?
No,
Not
we
really.
don't. We don't have the time to do it. And
Yeah.
sometimes we do some titanium guides
Oh, yeah. Yeah.
because I don't know, but can you choose the size of the nerve, meaning
Yeah.
the diameter of the
Yes, you can
nerve?
select it. Yes, you can select it. Yeah.
Because I saw it. It seems to me they were very fragile.
Oh yeah, there's yeah, it is, and the sinus window is maybe too short as well. Yes, you can adapt this, and you should definitely make your guides a little bit more tooth supported and bigger, of course. And some of these examples, just examples, and sometimes I use them this small so that I can place it under my flap. The smaller they are, the easier they are to place under the flap. But yeah, you should make sure that they are adequately supported. So you have to make your guide, to supported guide, a little bit bigger so it doesn't rock. So it should be certain that you're on the right path. Sometimes what I do is I just use a pencil and trace the guide window, and then use my piezo to enter the sinus and to collect
without the guide already. Okay.
Yeah, without the guide. Yeah. Well, this is something we have this for years. Well, the first guys I saw talking about this was Scott Gans and Marco Rimaldi and etc. They were doing this with stereolithographic models, and then we're actually on the model placing some acrylic and etc. Now you can easily combine all these things, the CBCT, and doing it in an affordable way. A very affordable way, such as using the BlueSky Plan software.
Okay, and you think it's easier than Mesh Mixer? No, it can guide you through. And
well,
even,
in Mesh Mixer, I can see exactly where I am. When I'm designing this, I like to be checking against the CBCT exactly where I am, and you don't get to do that on Mesh Mixer. You can export the maxilla, maybe. It's just gonna be, but you don't have the views that you have on BlueSkyBio, so it makes it
the 2D views. No, you can slice it on the 3D, which is almost.
I guess you could do anything, but it's just much simpler this way.
It's much simpler. And probably already it's a tool. Meaning, for example, planning putting software is much easier here. Then you already have a library of implants, and it already puts you the.
You can actually combine these things. Yes, you can combine automatically with the implant placement as well. So for me, it's a one-stop shop. So I really, really enjoy this.
Yeah, I think everyone stays a little bit with their with their mouths open with this. I don't see too much questions because in reality, this is really amazing what I have seen today.
Well, not that amazing, really, but it can be a bit overwhelming if you're not using BlueSkyBio. If you're not planning your implants already, then it can be a little bit overwhelming. But it's definitely the way to go, and we're using it. I'm using it a lot to communicate. Using it a lot with students in mind that that experienced, and they want to be sure. They sent me the file, and now it's like they have me on the surgery, and this exchange of information is priceless.
Mm-hmm. I was looking for another thing. You don't fix the guys, at least for harvesting
I
bone on
do.
the raiment.
I do.
You do. Okay.
I do. I do place a little hole so I can have a 1.3 millimeter osteosynthesis screw. I do for sure. The mandibular's one, yeah, for sure. But if I have teeth, I don't bother. I just whenever this is placed on the teeth and on the ramus, you feel it completely immobile, so I don't need it. But on an edentulous case, I would totally do it. I would totally, because it just, on an edentulous case, it is so easy for these guides to move. So you definitely need to have something to screw it. So I use a 1.3 by 5 millimeters or 7 millimeters screw, place it on the crestal, and I'm ready.
Pedro Pena is asking a question here. If you have the complete program, means I imagine this means software. This is all on BlueSkyBio. It's for free.
It's a free software. You need to buy the export. Okay, but as I'm saying, it's not an expensive thing, so you should totally check it out. There's another question: how do you control the osteotomy depth? Yeah, well, if you're talking about the ramus, what I do, I use piezo, and normally, the depth is, I try to trespass the cortical, so you feel it. You kind of feel it. Most cases, about 3 millimeters. On the traditional approach, if you're not using piezo and etc., maybe you'll do a 1 millimeter cut, but only on the apical side. And all the other cuts, mesial, distal, and crestal, you have to go a little like 3 millimeters. But you don't get to control with these guides the depth. That's not the point of these guides. The point of these guides is to know where you are, not control, because that's not. You can go a little deeper. It's not gonna change anything on this bone collection. It's certainly not gonna change a lot on the sinus as well. So yeah.
Another thing, just my question about the ramus. I noticed that while you are using the first guide, you make a subtraction of a cube, no? And that cube you cannot make it.
Make a subtraction. I'm sorry. I make a subtraction.
You made it the guide for a subtraction of a cube over the guide, no?
Of a cube over the guide.
Yes, you design a guide, then you design a cube, and you made kind of
a cube.
Yeah.
It's just you have this window. You can change the dimensions of this window. This is a window that it's there for another function. What you do with this window is, when you're doing a surgical guide, you need to check that it's in place. So you have this possibility to add a window, so you can be checking, and you get to place it whatever you want on your guide. So the thing is, you get to change the size of this window. So this makes it a very, very valuable tool to do these kind of things.
Okay.
So this is, you understand, this is a guide. You also have this thing. You have this on ExoCAD as well, and many other softwares. But in this particular case, you can change the size, and I like it that way.
So you print it in your share side, yeah.
Yeah, I print them. Yeah, I have a 3D printer, and yeah.
And this is the easiest part, no?
Yeah, that's very easy.
Yeah,
I mean, this will take me 30 minutes to print this. And,
which printer do you use, by the way?
Which
printer do you use?
Oh, Anycubic printer, just the simplest, reliable printer. You have Anycubic printers as well, don't you?
I also have Frozen, which I like a little bit more. There is one now that I buy, really amazing. It's not that expensive. Frozen Sonic, which is very, very fast, very, very precise. It's not that difference. It's about probably the double, but it's a double of 350 or something. No, it's not that much the double, and it. I think it makes a little bit the difference. Yeah. I like it very much.
Yeah. So
also, which is the surgical guide resin that you use?
Well, for these things, I would advise something like NextDent, SG, maybe Ars Labs as well.
Surgical guides, yeah.
Surgical guides by NextDent, I'd say it's the gold standard. But I've been using as well the resins from Ars Labs, which is a Russian company. Very, very nice. Very nice.
I think they are Ukrainian, no? Ukrainian, no?
Ukrainian. Oh, okay. Very nice resin. Very affordable resins. I like them very much. No odor, no smell. So those are the.
They have also for surgical.
Sorry.
They have also for surgical guides.
Yeah, they do. They do. Yeah.
Very good. Very good. Well, let me see about this question. What treatment do you give to the guide after printing? Well, you can tell it. Yeah. It's alcohol, no?
Yeah, alcohol. Yeah, chlorhexidine and alcohol. That's it.
Yeah. And we should not get away to alcohol this time at the time. No?
Yeah.
And another thing, do you have any experience with the new machines for cleaning? There is some new machines in the market.
What do you mean?
Yeah, just for cleaning.
IPA alcohol and that thing?
Yes.
No, I don't own one. I do my post-processing with something that I've made. I don't have a specific machine for that. And for curing, I use a composite curing light that I already have. So just I'm keeping it basic. I don't think you need to be complicate on that on those things. Keep it basic, and it has to work. And whenever you find a printer or material that works, then you're all set. But it can get very complicated, and you'll be outdated in every month. Every month there's something new, something better.
What you are telling us is that size doesn't matter. It's what we do with it. No?
Yeah. I think that's what I told you. Yeah, that's it.
Okay. Let's see if there's someone else doing some questions. Just people thanking you.
Thank you for being here.
Okay, and I will pass you. You will receive a message from Pedro after in your email, and if you need something, you can contact him anyway for further questions. Okay. Thank you, everyone, and good night. And thank you for being here with us tonight.
Bye-bye.
Bye.